Okay, hi Algebra 1 class. This is Mrs. Levenseller. Before we jump into our first unit, I just wanted to review with you two symbols that are going to pop up quite a bit. We're going to start classifying numbers, and you'll need to be able to recognize both the square root symbol and the absolute value symbol. So let's start with talking about square root symbols. Oops. Square root symbol looks like this. The general term for this is a radical, but this particular one is called a square root. Later in the year, hopefully we're going to get to radicals and all of their forms. You can have cube roots, you can have fourth roots, fifth roots, all kinds of values. This little guy out here is called the index. The reason that I know that this one that we're going to start looking at is a square root is because there's no value written out here. So when there isn't a value out front, I'm assuming it's like a little imaginary 2 that's telling me that it's a square root. Now the square root is the opposite function of squaring something. So it's the opposite operation. When you put those two things together, just like a positive 5 and a minus 5, if you put those together, you would get 0. If you put a square root and something that's squared together, they cancel each other out, and you're just left with the piece underneath, in this case, x. All right? So for our purposes, we're going to need to estimate some radicals here. So if we have a number line, all right, let's see if we can come up with some equivalent values for radicals, and that will help us estimate where they should fall on the number line. So because we're dealing with real numbers right now, I'm only going to deal with radicals that have positive values underneath. In the next video, we'll look at some radicals with negative values underneath, and the fact that that brings us into a whole different number system. But for right now, we're going to stay positive. So 0, 1, 2, 3, 4, 5, 6, and 8, 9, and 10. Perfect. So those are the basic numbers under number line. And what I would like to think about right now is what are the equivalent forms of these if they were written like a radical, okay? And that means we need to think about our perfect squares. So I'm going to start with 1, right? 1 is equivalent to 1 times 1, which is the same thing as 1 squared. Well, if I take the square root of 1 squared, I just get 1. So that tells me that those are equivalent, right? These two cancel each other out and give us what we want. So the square root of 1 squared is equal to 1, and the square root of 1 squared is the square root of 1. So on the top of the number line, I'm going to make the equivalent values up there. I know that the square root of 1 is the same thing as 1. Let's see if we can do that for 2. So 2 squared, or 2 times 2, should give us 4, right? Is the square root of 4 equal to 2? Yes, because the square root of 4 is the square root of 2 squared, and those pieces cancel each other out. So the equivalent form of the number 2 as a radical is the square root of 4. So all we're really doing is finding what's the square of the whole number on the number line that we have here. So with 3 is equal to 3 times 3, or 3 squared, which is 9. So that tells us the square root of 9 is equal to 3, right? They're opposite operations. So one undoes the other. So 3 is equivalent to the square root of 9. And let's go down the row and see if we can fill in the rest. Well, I know 4 squared is going to give me 16, so the square root of 16 must be equal to 4. 5 squared is 25, so the square root of 25 must be 5. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Oh, and I forgot 0 back here. I skipped over it because it's a little hard to think about sometimes. But 0 is the same thing as 0 times 0, or 0 squared. So we do know that the square root of 0 must equal 0. So the equivalent form for 0 is the square root of 0, just like the equivalent form for 1 is the square root of 1. Those two numbers are a little bit special. So there's our equivalent values. Let's see if this will help us estimate where a couple of radicals fall on the number line, right? We're just trying to get some number sense here. Oops, I accidentally deleted a couple things. Okay, so I'm going to estimate or approximate, because we're not going to get an exact value necessarily without a calculator, but we can come pretty close. So let's approximate the square root of 17 on a number line. And again, without a calculator, okay? So when you approximate, when you're comparing values, you want to compare them in the same form. So since I'm given a radical here, I'm going to look at the values that are written as radicals because they're written in the same form. And that's going to be very helpful for me when I'm trying to estimate where it falls. Well, 17, that number would be between 16 and 25. So I know that the square root of 17 must fall between the square root of 16 and between the square root of 25, right? Well, we know the square root of 16 is equal to 4, and the square root of 25 is equal to 5, so that means that the square root of 17 has to be a number between 4 and 5. Now we're estimating, and we want to be as accurate as we can, so let's think about how close 17 is to the two other values under the radical. Well, 17 is only one number away from 16, and 17 is 8 values away from 25. So if we're wondering what it's closer to, the answer is obviously that it's closer to the square root of 16. It's really close to 16. It's actually only one value away. So if I had to approximate, I would say the square root of 17 is approximately, and that's what those two, instead of a straight equal sign, those two squiggles tell us that means approximate. So the square root of 17, I would estimate, is about 4.1, just a tiny bit more than 4. So I would place it right about there. Okay. So I want you to try one. So can you approximate, let's say the square root of 57 on a number line. So pause the video and see if you can figure out where the square root of 57 would fall, and then resume your video and we will talk about it together. So hopefully you've had a chance to think that through. So if I look at the square root of 57 here, the square root of 57 has to be between the square root of 49 and the square root of 64, right? So we know the square root of 49 is equal to 7, and the square root of 64 is equal to 8. So the square root of 57 must be between these two things. Well, the square root of 49 and the square root of 57, there's a difference of 8 numbers there. And the square root of 57 and 64, there's a difference of 7 numbers there. So 57 is almost smack in the middle of 49 and 64, which tells me if the whole number equivalents are 7 and 8, the square root of 57 should be about halfway between those, so about 7.5. So that's my estimate there, okay? And so use that same type of logic whenever you're trying to estimate a radical, okay? And if you come across something like, let's say, 3 square roots of 2, maybe something like that, you can use the same kind of logic, but this is really saying 3 times the square root of 2. So the first thing you would want to estimate is, where is the square root of 2 approximately? And then you want to multiply that by 3. Because 3 is a whole number outside of the radical. So if I look at the number line, Well, the square root of 2 has got to fall between the square root of 1 and the square root of 4. It's closer to 1 than it is to 4, so maybe 1 point, let's say, oops. But there's not a lot of value between 1 and 4. There's only 3 numbers there. So it's going to be probably close to half, but not quite all the way, excuse me. So I'm going to estimate the square root of 2 is about 1.3, 1.4. Okay, you could use a calculator and find the exact value, but right now we're just estimating. But if it's 3 radical 2, then I would take 3 times my estimate, 1.4, and that would give me its approximate place on the number line. Okay, so this is just a simplified form of a radical, but you might run into that as well. Okay, so the other symbol we're going to look at briefly is the absolute value symbol. And that's just the 2 bars on either side of either a number or a variable. Absolute value is a number's distance from 0. Okay, so if, let's say I want to find out what's the absolute value of 3, well, if I go back to my idea of a number line again, the absolute value of 3, well, 3 has to be 3 spaces away from 0. So if the value is, if I'm asking the absolute value of 3, it would just be positive 3, right? This distance here, this concept is always a positive value because distance is a positive concept, right? Then when you start to put in a negative, that talks about direction. But if we just want to know the value, how far away is something, we're going to talk about that as a positive number. If you get into physics at some point, you'll start to learn about vectors, and those really take in both a magnitude, which is how big something is, like the absolute value, and a direction. And that negative sign is really giving us a direction, but that's not what we're asking here when we have absolute value. So we don't have to worry about the negative unless it's outside the symbol. So if I wanted to know what's the absolute value of negative 1.5, well, negative 1.5 is between negative 1 and negative 2, and that is just 1.5 spaces away from 0, so that's its absolute value. The only time you're going to get a negative answer from something like this is when there's a negative number on the outside of the absolute value symbol. So maybe I want to know the negative absolute value of negative 2. Okay, so just like with PEMDAS, we're going to attack our grouping symbols first, and absolute value works like a grouping symbol. So the first thing I'm going to ask myself is, what is the absolute value of negative 2? Well, how many spaces away from 0 is negative 2? It's 2 spaces. So the absolute value of negative 2 is 2. This negative sign out in front of that is saying to make that answer opposite, okay? So we're not distributing through the absolute value signs, we're just applying the idea of this negative after we've taken the absolute value. So I just want to make my answer to what is the absolute value of negative 2 the opposite sign. Well, the opposite of positive 2 is negative 2. So you can get a negative answer when you're dealing with absolute value, but just remember whatever comes out of just the absolute value symbols, that will always be positive. Okay, if you start to apply negatives or add, subtract, multiply, and divide something to the absolute value, then your answers might become negative. But if it's just straight absolute value, your answer will be positive.